Okay, introduction says the slow and sloppy seven were getting in the groove with the tours and realized that they were always going to pay $40 per ticket plus the price of gas. They also realized they always knew two of the three important numbers regarding each trip: the amount of people going, the cost of gas, or the amount of money they could use for the total trip. They wanted to figure out an easy formula that their new groupie manager, an 8-year-old younger sister, could use to let them know the missing number. So question 1 says, what formula could they give the manager if they needed to find out how much money they could spend on gas? Well, let's go ahead and look at what they talked about. We know it's always going to be $40 per ticket, and we have to always multiply that by the amount of people going. Then we always added the gas into that, and we know that that equaled the amount of trip. Okay? Our 8-year-old manager doesn't quite know how to solve equations, so we're going to try to figure out an easy way where all she has to do is just plug some numbers into a calculator and she gets the answer. So again, the question is, we want to figure out how much they can spend on gas. So we want to get this gas part by itself. Well, that means that we're going to take the amount of money that we have on our trip and we're going to subtract the $40 times the amount of people going. So what kind of formula could it be? Again, amount of trip, and we're just going to tell her to take that number and subtract the $40 times the people going. That's going to equal how much money we have left over for gas. Okay, when we look at formulas, that's kind of a weird looking formula, so let's go ahead and use the algebraic way. We're going to say that people equals P, because usually we don't have words in our problems. So we know that gas equals G, and we know the amount of trip is going to equal A. So rewriting this, we're going to take the amount and we're going to subtract the 40 times the P, and that's going to equal how much we have left over for gas. Okay, that looks kind of weird. Probably for an 8-year-old, this is what we would give her. But again, that would be kind of the formula that we would use. That way she wouldn't have to do any algebra. She would just plug it into a calculator. So this next one says, what formula could they give the manager if they needed to find out how many people could go on the trip? Okay, well again, we know that we have our amount of trip. We're going to get rid of the gas money for that. So we have our amount of trip. And if we subtract the gas money, that's how much we have left over for our tickets. Okay, equals the $40, basically equals the tickets, which is $40 times that people. Okay, well again, we just want to figure out the people. So that means that we're going to have to take our amount in our gas, subtract that, but then whatever our answer is, we're going to divide by 40. So we need the amount minus the gas. She's going to do that. And then we're going to have her divide by 40 in order to figure out how many people. Okay, again, algebraically, we're going to go ahead and use the same type of, or the same variables up here. So I'm going to say that it's the amount minus the gas. Remember, we don't like a division sign, so I'm going to take that and divide it by 40, and that's going to tell us how many people can go on our trip. Realize that we are actually solving equations still. We were solving for G, the variable G up here, for gas. We were solving for P, for people down here. Just notice that our answer, we are solving an equation, but our answers are starting to look kind of weird. These are what are called literal equations. Students don't like these because, again, our answer isn't P equals 2. It actually is P equals amount minus gas divided by 40. But, again, we're going through the same steps. So, looking at this up here, okay, we were trying to get that P by itself. So we were adding or subtracting. We subtracted the gas over. And then we had to multiply or divide. So we divided by that 40. So we are still going through the same steps. It's just our answer is going to look a little bit different. So that's the literal equation part of this section. Now we're going to look at what's called dimensional analysis. So looking at this next problem, it says that the next concert is in Williston, North Dakota. Checking Google Earth, it states that it's 663 kilometers from Pierre. Well, they want to figure out how many miles that is. So a couple ways to do this. When we look at dimensional analysis, this is another section where kids do really well without having to set up an equation sometimes. Sometimes they understand what to do with these numbers. Other times they struggle. So I'm going to show you how to actually set up the whole dimensional part. We understand that we have 663 kilometers. Okay, we want to convert that over to miles. So what we're going to do is we're going to multiply by something that actually, again, this is the fun part of algebra, we're going to rewrite the number 1. We can rewrite the number 1 however we want. 2 over 2, 3 over 3, negative 6 over negative 6, and that's not going to change our problem. So looking at this, I want to actually cross cancel and get rid of kilograms, or I'm sorry, kilometers, and change this to miles. So that's the first thing that you do with a dimensional analysis problem. Write what it is that we have, and we're going to cross cancel. Just like we did in last section, we're looking at this as a fraction, that this is 663 kilometers over 1. So I'm going to get rid of the kilometers, and I'm going to make that into miles. Okay, so then I'm going to go ahead and fill in the blanks. And I can do it 2 different ways. I'm going to use this one first, and then I'm going to go ahead and look at that one. All right, I know that 1 kilometer, so this is a 1 kilometer, is 0.62 miles. So I understand that this is 0.62 right here. Okay, again, the reason why I set it up like this is because it's not the numbers that I want to cross cancel, it's the label. I just cross canceled the labels of kilometers, and now I have it into miles. Now I know what I'm supposed to do. I'm supposed to take the 663 and I'm supposed to multiply it by the 0.62. And I end up with about 411 miles. Okay. Looking at it the other way real quick, again, we can go ahead and see that we have 663 kilometers. We're still going to set up the problem. Again, I want to cancel out my kilometers, so I want to put that in the denominator, and I want to figure out what my miles are. So here, I'm going to change this up a little bit. I'm going to fill in the blanks. They tell me that 1 mile is 1.6 kilometers. And to explain what this is, since these two are equal to each other, I really didn't change this problem. Again, this actually equals the number 1, and any number times 1 is itself. So I didn't change anything. I just wrote the number 1 in a very fancy way. So here, look at this. I cross-canceled my kilometers. Now it looks like I'm taking 663 and dividing it by 1.6. Actually gives us, I think, 414 miles. Okay, so this is called dimensional analysis, converting between 2 different conversions, 2 different measurements of some sort. Okay, again, some kids could just realize that right away that we're taking 663 and multiplying it by 0.62, but I do want to set it up like that. All right, one more. It says all of this driving has worn out the tires on their car. While it's in the shop, they have to take a loaner car, and the speedometer doesn't work. They didn't budget a speeding ticket into the cost of the trip, so they need to determine how fast they're going. That way they can just stay at that speed. Using a stopwatch, they found out that they were going 1,000 feet in 14 seconds. Well, the question is, how fast were they going in miles per hour? So this is another conversion. We want to take feet, convert it to miles, but we also want to take seconds and convert it to hours. So when we look at this, this is 1,000 feet per 14 seconds. So in conversions, we're going to write that as 1,000 feet per 14 seconds. Okay, always write it as a fraction. Okay, I'm going to focus on the feet part first. I want to get those feet into miles. So again, I want to cancel out the feet, which means that I'm going to put that in the denominator. I want to convert that into miles. Well, this is the fun part. We have to figure out how many feet there are in 1 mile. So in 1 mile, there are 5,280 feet. Okay, I did my first part. I converted over to miles. Now I have to actually look at these seconds, and I have to get that into hours. So this is kind of tricky. I have my miles down. I'm going to stop that part, and now I have to look at these seconds, which means that my seconds, in order to cancel them out, actually is going into the numerator because I need to cross cancel them out. Okay, I'm not quite sure how to go from seconds to hours, but I know how many seconds are in a minute. Okay, there are 60 seconds in 1 minute. Not quite there. I did cancel out my seconds, but now I'm going to have to cancel out those minutes and get it to hours. So there are 60 minutes and 1 hour. Again, I'm cross-canceling the label, not the number. Now I have a huge crazy mess. And what we do is we look straight across, we multiply all of those numerators together, and then we divide it by the denominator. So when we put this into our calculator, let me pause for a second and I'll open up the calculator and we'll look at this problem. Okay, multiplying this straight across. I'm going to use that parenthesis because since I'm dividing, I'm going to say that I'm going to take 1,000. I'm not going to multiply by the 1. I know what that is. But times this 60 times another 60. And I'm going to close the parenthesis because I'm going to say take whatever that is and divide it by, in parentheses, 14 times 5,280. And that's going to convert it over. So how fast are they going? About 49. And look at this. So here's our labels, miles. So I'm going to write this up here. We cross-canceled everything to get to be 49 miles per hour. Okay, I did spend some time on that, a little bit more than maybe needed, but just understanding how to cross-cancel. We're cross-canceling labels. Everything that I multiplied this by actually represents 1, the number 1. I didn't change the value of this. I just converted it over to different labels. And again, that's what we're going to be doing in this section. So go ahead and get out your notes and vocab for this section. Okay, objective for this section is to solve equations with coefficients represented by letters. So again, that's the literal equation part, that we're actually going to have answers with variables in it. We're also going to solve real-world problems that require converting units of measure, like we did on that last problem. Okay, so solve for a specific variable. Some equations, such as the one above, contain more than one variable, or I'm sorry, the ones that we dealt with. More than one variable because we dealt with G, gas, A, amount, and then P as in people. At times, you will need to solve these equations for just one of those variables. So let's go ahead and look at example 1. We're supposed to solve 4m minus 3n equals 8 just for m. So again, solving, we want to get m completely by itself. All right, we're going to focus on this. Step 1, we always add or subtract. I have a minus 3n here. And I understand that there's multiplication in there, but remember the only variable I care about is m, as in monkey. So I'm actually going to add this whole thing to each side. So I have to undo a negative 3n, which means I'm going to add that 3n to each side. I'm also going to stop myself and rewrite this problem before I go any further. That way I have room to work. Again, I want to add 3n to each side. And here's another tricky part. When I look at this side, I have 4m equals what? Okay, think about combining like terms. Can I add these two together? No, I can't. Because again, this has a variable n, this one does not. So I can just add that 3n over to that side. Again, I'm focusing on this m. I have to get this m by itself. So I'm going to read this 4 times n. How do I undo multiplication? I'm going to divide by 4. Over here, I have to divide the whole problem by 4. So final answer, not very pretty. We're not going to get really nice answers. M completely by itself is 8 plus 3n divided by 4. Add or subtract, and then multiply or divide, focusing on the variable that we have. If that's hard to do, look at this negative 3n and just pretend that that n's not even there. Just think, okay, it's a negative 3, I would have to add that over, and then take the n along for the ride. All right, go ahead and try these guided practice. Again, I would recommend really zoning in on that one variable that you have to solve for, and then figure out, okay, add or subtract first, then multiply or divide. Unless, as a hint, there's division in the way. Okay, go ahead and try them and I'll put up the answers. Okay, with these type of problems, there's always so many different stipulations that I'm going to stop with just 1A and 1B, and then we'll work 1C and 1D together. So with 1A, again, we were solving for n. I'm honing in on that n and saying, okay, I have to add or subtract first. I have this piece out here that's floating around being positive, so I need to subtract that to the other side. Doesn't matter that there's a variable. I'm taking the whole piece and subtracting it over. Remembering that I can't combine those guys. So this just turns into 15 minus 6p. That 3 means that I'm multiplying it, so I have to divide it on each side. So I'm going to take both 15 and minus 6p and divide by 3. Then I'm going to look at this, and actually this is what I call the triangle. If all 3 of these have a common factor in them, then we can actually simplify it down even further. 15 divided by 3 is 5. Negative 6 divided by 3 is negative 2. The only way you can do that is if both of these numbers have a factor of 3 in common. So best answer for 1A is n equals 5 minus 2p. Looking at 1B, again, usually we add or subtract first, but this division is in the way. So we're going to focus in on that and say, okay, in order to get rid of division, I'm going to multiply each side by 5. Well, 11 times 5 is 55, and then that j is right there. Then we're just down to k minus 2. So very close to solving for k, all I have to do is add that 2 over. And remembering that I can't combine that with the 55j. I just have to say 55j plus 2. Okay, looking at 1c, we have parentheses in there. Most of the time, this is that other step where we're going to have to distribute that through. But let's go ahead and see what we're solving for. So looking at this, we have 28 equals t times the quantity of r plus 4. And we want to solve for t. Okay, well, let's look at this. What's happening to t? We are multiplying it by this quantity. So how do you undo multiplication? We're going to divide. So rewriting this, since we're multiplying by that whole quantity, I'm going to actually take it and divide by the whole quantity. That parenthesis states that I can do that because it's both of those pieces that I'm multiplying by, so I'm going to divide by both of them. So final answer, t equals 28 divided by r plus 4. Okay, students want to look at this and say, oh, well, I can simplify that 28 and that 4. No, you can't, because there's nothing out in front of that r that has a factor of 28, so we have to leave it exactly like this. So always read that problem in your head, understand what it is you're trying to solve for, and how to undo what is around it. So same thing on this one, 1D. We have a times the quantity of q minus 8 equals 23. And we want to solve for q. Okay, well, what's happening to q? The first thing that's happening to q is it's being multiplied by an a. So how do you get rid of multiplication? We have to divide by it. And this, again, is where multiplication is in the way. We can't get to that 8 until we get rid of that a. So that means I'm going to undo multiplication, I'm dividing by an a. So I'm left with q minus 8 equals 23 divided by a. Okay, now what can I do? Well, last step. I almost have q by itself. I'm just going to add 8 over here. And where does the 8 go? Just out here on its own. So final answer, q all by itself is 23 divided by an a plus an 8. Again, read it in your mind. Figure out what the operations are. Zone in on that one variable you're trying to solve for and undo all of those operations around it. Doesn't matter if it's a variable or if it's a number. Just undo those operations. Okay, looking at example 2, we have solving 3x minus 2y equals xz plus 5. We're supposed to solve for x. Well, this is kind of tricky because look at this. This is one of those where the term is on both sides. So we can't really do anything with this problem until we get those terms on the same side. And this is where the fun begins because look at this. Usually we have that stipulation, well, if they're both positive, then you're going to subtract the smaller one. Well, there's a z attached to that. So is that smaller or not? We don't know. But we do know that we want to get that x to the other side. So this is, since this is positive, we want to undo that and we're going to subtract an xz from each side. All right, so we have 3x. I'm going to put the minus xz right beside it because I know those x's are together. Minus 2y, and that equals just a 5. So I have the x's on the same side. Okay, that's probably some good news. I have this minus 2y in the way, so I do want to get rid of that. So again, I don't care that there's a variable on there. I have to add him to the other side to get him away from the x. So I'm going to add 2y to both sides. I have 3x minus xz equals 5 plus 2y. Okay, I'm getting closer. But here's a problem. Because I have x's in there, but I have this 3 and the z attached to each one of them. Well, this is what I'm going to do with the distributive property takes the number and it multiplies through. This is kind of the reverse distributive property. I see that they both have an x in common. So I understand they have an x in common. I'm going to put in parentheses, so I'm kind of hitting the reverse button, what was left over. Well, I took an x out of this part. I have a 3 left over. I took an x out of this term. I have a negative z left over. So reverse distributive property. If you want to hit the play button and distribute that back through, I have the same problem. So I know that this equals 5 plus 2y. Okay, I'm getting closer because I have only now one x, which is much better than this ugly mess up here. Now I have to figure out what I'm doing with that x. X times the quantity 3 minus z. Well, I'm multiplying. So in order to undo multiplication, I have to divide by a 3 minus z. Okay, notice I'm taking the parentheses away. That's okay in this situation. If you want to keep those parentheses, you can. So final answer. That cancels those two out. So I'm left with an x that equals 5 plus 2y divided by 3 minus c. And this is what you call a pretty crazy answer. So again, if you have two of the term that you have to get rid of, get them on the same side like we did. And then hit that rewind button on the distribute property. Say that they have an x in common, and then state what's left over. From there, then you can divide the rest of it off of the problem. Okay, try this 2a and 2b, and I will put the answers up. Okay, looking at 2a, again, we have d plus 5c equals 3d minus 1, and we're supposed to solve for d. So first thing that I'm going to do is I see that I have a d on each side. The rules of solving equations say I'm supposed to combine like terms. Well, here we can actually do that because we don't have any other variables attached to this. So I'm going to subtract a d from each side, which leaves me 5c equals 2d, because 3 minus 1d is 2d, minus 1. Then from there, I can add my 1 over. I can't combine these two, so I just leave it as 5c plus 1. Then I'm going to divide that too. So here I didn't have to do that distributive property section because I didn't have a letter coefficient basically attached to my variable. Looking at 2b though, it does say that I'm supposed to solve for q. So looking at the problem, I do have a 6q and I have that weird qr thing. But again, I have to combine those terms. I have to get them to the same side of the equation. Here I can't combine them because this coefficient is a letter. So I'm going to go ahead and go through the steps I can. I added that 18 over. And this is where I just have to get one q. So since they both have a q in common, I'm going to state that there's a q in common. What's left over is a 6 minus an r. So I hit the reverse button on that distributive property. Then I realize that I'm multiplying that piece. I'm trying to get q by itself, so I'm dividing that 6 and the minus r all together because I'm taking that whole parenthesis and dividing it out. So final answer on that one is t plus 18 divided by 6 minus r. Again, they're called literal equations because we're going to have quite a few variables attached to our answer. And that's this part right here. It says an equation that involves several variables is called a formula or a literal equation. To solve a literal equation, you apply the process of solving for a specific variable. So a lot of times we see these type of formulas in geometry. This example says use the information about the largest yo-yo at the left. The formula for the circumference of a circle is c equals 2 pi r, where c represents the circumference and r represents the radius. So we're supposed to solve that formula for r. Well, let's look at this formula. Let's go ahead and rewrite it. C equals 2 times pi times r. And the reason why I said that out loud is because I'm multiplying by both a 2 and a pi. And since I'm multiplying by both of them, I want to get rid of both of them. So how do I undo multiplication? I'm going to divide by both a 2 and a pi. And I can divide by both of them at the same time. So gets rid of everything around the r, and I actually have r solved for. R equals their circumference divided by 2 pi. Now it says we're supposed to find the radius of the yo-yo. Well, looking at it, it says that the largest yo-yo in the world is 32.7 feet in circumference. It was launched by crane from a height at 189 feet. That would have been fun to see. But again, we know circumference now. So we know our radius equals circumference, which is 32.7 divided by 2 pi. Okay, handy dandy calculator out. We're going to put this in exactly how it's written. So we're going to say 32.7. We're going to divide that by, again, if there's more than one piece to your denominator, go ahead and put those parentheses. 2. I'm not even going to hit that multiplication sign. These calculators are awesome. There's my pi button. So I'm going to say 2 times pi. So second caret, close that parenthesis, and what do we get? About 5.2. Let's look at this. We're talking about feet. So the radius of our yo-yo is about 5.2 feet. Okay. Solving it for the variable that we're looking for, that way we can just plug in what we have. No using algebra, throwing it into the calculator and finding it out. So go ahead and try guided practice 3 that again deal with some geometry type of formulas. Okay, first problem tells us to take that volume formula and solve for W. So pretty simple, we're multiplying all 3 of those pieces, so we divided 2 of the pieces out. And then B actually tells us just to plug in some values for each one of those. And again, this is where some students don't like literal equations because they could have just used that normal formula and plugged it in. But especially architects, those type of people that deal with dimensions a lot, instead of having to go through 4 different steps. Here, all they have to do is plug in one formula quickly in order to find an answer. So sometimes it is nice to change the organization of a formula in order to just solve for one variable. That way it's just a plug and solve at the end. So again, literal equations. All right, one last thing that talks about that dimensional analysis where we're converting between two different measurements. So looking at the running, it says a 10K run is 10 kilometers long. If 1 meter equals 1.094 yards, use that dimensional analysis to find the length of the race in miles. Okay, so here we go. We are trying to get from kilometers down to miles. So the first thing that I'm going to do is, again, I'm going to write what I know. I know that I have 10 kilometers. I know that I'm going to convert that. And the first thing that I know is that I have to get rid of that kilometers. So I'm going to put kilometers in the denominator so that label will cancel out. Now I have to kind of look at all this information and figure out what I'm going to compare it to. Well, I have yards, which doesn't really help me out. I have a meter. So let's go ahead and compare it to meters. Okay, I know that 1 kilometer, kilo means 1,000, equals 1,000 meters. So I at least have meters. I got rid of kilometers, I'm down to meters. Well, not quite there. I have to get rid of meters and I have to compare it to something else. Well, what do I have to compare to? Yards. So let's go ahead and compare that to yards. And they told me how to fill in those blanks. I know that 1 meter equals 1.094 yards. Okay, again, the reason I did that was so I can cancel out those labels. I still haven't changed that 10 kilometers because I multiplied technically by 1. I multiplied by 1 again. Okay, I'm getting closer. I need miles and I'm down to yards. So, got to keep going. I need to get rid of yards. Do I know anything about miles? Yes, I do. So I can go ahead and compare that to miles. They tell me that 1 mile equals 1,760 yards. Okay, so there I go. I went from kilometers to meters to yards, and now I have it into miles. So in my calculator, I'm going to multiply all of those numerators together, and I'm going to divide it by all of the denominators. So in parentheses, I'm going to start with my 10, multiply it by my 1,000, multiply it by my 1.094. Whoops, that did not work. There's a cool little button right here, that delete. I'm going to delete that too, and I'm going to insert a decimal. It's pretty cool. And then right here, I'm going to close my parenthesis. Then I'm going to divide by the 1,760. And I end up with about 6.2 miles. Okay, set up what you know, cancel out labels until you get what you need to know. All right, here's one that we kind of talked about with how fast they were going. Again, a car travels a distance of 100 feet in about 2.8 seconds. What is the velocity of the car in miles per hour? So let's set it up like we did. We have 100 feet per 2.8 seconds. So the first thing that we want to do is focus on that feet. We have to get that feet to miles per hour. We want to cancel out feet, and we want to convert that to miles. Well, we know conversion, 1 mile is 5,280 feet. So like last time, look at this. We canceled out our feet, we got our miles. Now we have to get the seconds to hours. And I don't have to start a new problem. I'm going to go ahead and just keep multiplying because, again, it's this label that I focus on. I have this in the way, but it has nothing to do with my seconds. I want to get rid of seconds. I can compare that to minutes because I know that there's 60 seconds in 1 minute. Seconds are gone. One last step. I have to get rid of minutes since it was in denominator. Here it is in numerator. And I can compare that to hours. I know that there's 60 minutes in 1 hour. So I went from feet to miles. I went from seconds to minutes down to my hours. Calculator states, I have to get rid of this over here. We have 100. We're multiplying that by 60 and by 60. And we're dividing that by 2.8 and 5,280. So how fast is that car going? About 24. It says round to the nearest whole number. So we are going to say about 24 miles an hour because we're going to round that down. Okay, set them up as fractions and cancel out those denominators. A lot of information in this section. Go ahead and give it a shot in the assignment.